Yes. Yes. Right.
So 11 to 10 to answer.
So,
10 to answer.
experiment techniques. 20 meter. This is used to be water from the English fringe with of waters. Directly we can take this as beta in a medium is beta by refractive index. Beta by refractive index. Hmm. Here angular fringe width is given as beta. Beta by refractive index. 2, 2. So it is mentioned that in Young's double slit experiment, two slits are illuminated by light of wavelength 5890 angstroms, and the distance between the fringes obtained on the screen is zero point 0.2 degree. Distance between the fringes means we call as angular separation, fringe width, angular fringe width. We will call it as angular fringe width between two fringes is beta. Actually it is equal to how much? 0.2 degree. Fringe width, if you are measuring in meters, we will consider meter beta. Angular fringe width you can take it as theta also, no problem. Okay, so let us see.
It is theta or beta, sir?
Let us say some. Let us use some usually, but beta is a d lambda by d we will use, right? For that purpose, you can use this as theta to avoid that confusion. We call this as angular fringe width. Fringe width. Width. If the entire setup is immersed in, if the entire our whole apparatus is immersed in water, then the angular fringe width will be provided. The refractive index of water is 4 by 3. So in water, if the angular fringe width, if you take it as theta dash, what is this theta dash? If the refractive index of water is equal to 4 by 3, if it is immersed in water, we have to remember that this will be decreased by this. Or you can say that the angular fringe width or linear fringe width or whatever it is in a medium, if it is beta dash in a medium, it is equal to beta by mu, or if it is theta dash in a medium, it is equal to theta in a free space by mu. So what will be this? Theta is given as 0.2, right? Yes, and
0.15.
point 0.33, or you can write it as theta is 0.2 divided by 4 by 3. 4 by 3. So this 3, if you take to numerator, you can write it as 0.2 by 0.2 by 4 into 3. So it is 0.6 by 4. Actually 1 by 4 you can take it as 0.25. 1 by 4 should be 0.25. So 0.25 into 0.6. So you can take this as 25 into 10 power minus 2 into 0.6 into 10 power minus 1, or 25 into 6 into 10 power minus 3. So 10 power minus 3. So 25 6 is how much? 25 4 100, 150. So you can write this as 25 into 6 maxima. Phase difference should be integral multiple of 2 pi, actually speaking. 2 n pi or integral multiple of 2 pi. Phase difference. Path difference is delta x is equal to d sin theta. For should be path difference. This should be equal to integral multiple of lambda. Integral multiple of lambda. Then we'll get, if the path difference is this, either 1 lambda, 2 lambda, or even 0 and 1 lambda, 2 lambda, 3 lambda, all, we'll get constructive right fringe maxima. For a destructive, 2n minus 1 into lambda by 2 we'll get. Okay. So, how many number of, how many this will get when d is equal to 2 lambda is the question. How many number of maximas? The condition for maxima is path difference d sin theta is equal to this. Got it? Then from this what you can say, sin theta n is equal to d sin theta by lambda, right? Yes. If you take this sin theta, nothing but y by d, and hence you can mention this as d is equal to 2 lambda by lambda into sin theta. Then you'll get then you will get 2 into sin theta but here for bright fringes you have mentioned that for slit separation. Separation from this. This is this one. Okay. Then this one.
Yes, sir.
0 divided by this one. Beta is value. Yeah. So question number 14. So it is given that two identical coherent sources produce zero order bright fringe on screen. Zero order bright fringe means what? Central bright fringe, right? Two slits are there, S1, S2. And giving zero order bright fringe means at the center. This is called as zero order bright fringe, right? Central bright fringe. Okay. Two identical coherent sources produce zero order bright fringe on the screen. Means their intensity should be same. If beta is the bandwidth, if beta is bandwidth, and beta is bandwidth, that is the minimum distance between two points on either side of the bright fringe. Then the minimum distance between 2 points on either side of the bright fringe where the intensity is half that of the maximum intensity is. So the minimum distance of a point on this side or this side, if you take it as y, this is y and this also should be y. Minimum distance between 2 points on either side of the bright fringe where the intensity is half that of the maximum intensity. Maximum intensity you will get here, right? Let us consider this is first point. So here intensity is IR1. Here let us say the intensity is IR2. Okay? The given condition is what is this distance y at which the intensity will be equal to half of the maximum intensity. Maximum intensity is IR1. You can take it as half of the IR1. Understood? So let's take this condition now as IR2 is equal to half of IR1. Usually IR1 maximum intensity is nothing but 4I0. 4I0. So this is it. Let us bring this, let us keep this as it is and let us simplify further. For this condition, what will be the y you are asked to find? So from equation 1 you can say, 1 you can express as IR2 is 4I0 into cos square what? 5 by 2. in terms of, because we want y, you need in path in terms of path difference. So we can write this in terms of path difference. In terms of path difference, it is pi by lambda into x, right? Yes, this is equal to 1 by 2 into, at this central maximum, you can express this as, of course directly you can write it as 4 I naught, 4 I naught only, right? Yes, the center thing is 4 I naught. Hmm? Now to simplify this, actually, hmm, if you simplify this, you get cos square pi by lambda into x is equal to half, half. So, hmm, hmm, hmm. Okay. So from this you can write cos pi by lambda into x is equal to, if you send this square this side, it becomes 1 by root 2. This is the angle part. So for what angle you will get 1 by root 2? For pi by 4 degrees, 45 degrees, right? So from this you can write pi by that angle part, pi by lambda into x is equal to uh, pi by 4. 45 degrees means pi by 4. Yes. So from this, if you simplify this, you get x is equal to, lambda goes here, you get lambda by 4. For this path difference, intensity at this point equal to half of the maximum intensity. Once you know this, what you are asked to find? What is the minimum distance from the central vertex? Y. This is equation 1, let us say. This is actually what path difference. You can take delta x if you are uh, having confusion also. Yes, you can keep as x also. Delta x is this, but also delta x is nothing but d sin theta is equal to d tan theta. This is equal to y by capital D. Yes, d into y by capital D. D into, this is y by d. So d into y by d. So let us say this is 2. If this is delta x equal to this is delta x equal to this. Left hand sides are equal. If you equate the right hand sides, you can write d into y by capital D is equal to lambda by 4. From this you can say y is equal to d lambda by 4d, 4 into small d. But I can say because d lambda by small d is fringe width beta, you can replace this part with beta. You can replace this part with beta and you can write y is equal to beta by 4. At this distance, you get this condition. Okay? Yeah. Right. this one. So question number 47. Page number 47. Collisions. So what is given here is, the question is, a plastic ball falling from a height 4.9 meters rebounds a number of times. If total time for second collision is 2.4 seconds, then coefficient of restitution is. We have to remember that if a body is dropped from rest from a height h onto a surface, okay, before touching the ground or striking the ground, the final velocity will be v is equal to root 2gh. With this, it will strike this. You have to consider this is the first body and the ground as second body. So you have to consider this like this: a body is colliding a heavy body, first body, second body, which is at rest. It is having initial velocity which is equal to v. Its initial velocity is 0. You have to just consider like this. Okay, this will be elastic collision. Because it is a heavy one, it will not move even after collision also. Final velocity of this will be 0. This will bounces back, but not with same velocity here. Okay, with some different velocity because it is not elastic collision. So that velocity can take after first collision, the velocity with which it bounces up is you have to take it as v1. So here it will try to raise to some height h1 in this case. So what is mentioning here is, if height of this fall is h is equal to 4.9 meter, it rebounds so that if the total time for the second collision, for first collision, after first collision it goes up, then comes down, then again after second collision it goes up to some height h2, right? So the question here is, if the total time for second collision is 2.4 seconds, means just to take second collision means it has to come down, then go up, come down, then it will go undergo second collision. So till here it takes this much time. That means if, let us say to from here to come down, let us say it takes time t. Then it goes up, for going up it, let us say it takes time t1. Then the same time it takes for coming down. So the total time to go from here to t1 before second collision. So the total time is t is equal to, I can say this is or I can say you can use capital T. Capital T is equal to, if you say this is T, this is T1 up, T1 down, so T plus 2T1 is total time here till second collision. This is given as how much? 2.4 seconds. 2.4 seconds. Then what is coefficient of restitution is the question. Then what is coefficient of restitution? How to find this? By using this, you may ask. How to find time taken to travel this? You have to remember the freely falling motion case. So for a freely falling motion, what is it? By using v equal to u plus ct, as u is 0, final velocity will be equal to square root of 2gh. Here final velocity will be equal to square root of 2gh, u will be 0. By using v is equal to u plus at, here a is minus g, you can write it as u is 0, so minus g into t. This time taken can be expressed as what? V is equal to t is equal to what? Actually v is also downward only, minus v, you can say minus minus gets cancelled, so v is equal to gt. From this t is equal to v by g. V is square root of 2gh by g. If you take this under root, you will get square root of 2h by g, so it is equal to square root of 2h by g will be the time taken here. From here to here, t is 2h by g, t1 is 2h1 by g. Alright, so but actually h is given. H1 will be the height raised after first collision. You have to remember that general relation. After nth collision, what is the height raised? Okay. So if you remember this as a general equation, You can take this as T is equal to, T can be expressed as T equal to T plus capital T equal to T plus 2T1, where T is square root of 2h by g. It is equal to T plus 2T1. It is equal where T is square root of 2h by g plus 2 into 2 into, what happens here is we have to take this as in terms of coefficient of restitution. The height raised after nth collision is nothing but e power, do you remember the general relation? Hn is equal to h e power 2n into h. After first collision, you want h1. What is this? T1, 2 into T1. T1 is, you can write it as square root of 2 h1 by g, where h1 is after first collision height raised is first collision means 2 into 1, so e square into, what is this, h, e square times h, e square times h. Did you understand? Got it? Now if you substitute this here, what you will get, this is equal to square root of 2h by g plus 2 into square root of 2 into h1 is e square h, e square h divided by g. Here this is e square, if you take it out it becomes e. Got it? So this further can be expressed as uh, square root of 2gh by 2h by g plus 2e into square root of 2h by g. 2h by g, 2h by g is common. If you take this square root of 2h by g out, you get 1 plus 2e. This will be the total time. The total time is 2.4 seconds. And height is given. G is known. We are asked to find coefficient of restitution. So this is known. These are all known parameters. You can find out this, right? So how can you do this now? Is the time given is how much? 2.4 seconds, sir. 2.4 seconds. Yeah. So if it is 2.4 is equal to square root of h is 4.9, right? 2 into 4.9 divided by g is 9.8. You can take 9.8 into 1 plus 2e. You want e, so keep this and you send here, and let us simplify this first. What will you get? 2 into 4.9 is 9.8. This gets cancelled. Got it? So you get just 1. So simply you can say 1 plus 2e is equal to 2.4, or 2e is equal to 2.4 minus 1 is 1.4, and hence e will be, what is the question number? 0.7, right? 0.7. That's it. Therefore e is equal to 0.7. You see here, question number 48. So did you remember this? This is a general formula. You have to remember this. All these relations. The height raised after nth collision is hn is equal to u put 2n into h. Right? Similarly, the velocity after nth collision. All these basic points related to this bouncing of a ball in collisions is what you have to remember. Yeah. Height raised after nth collision is e power 2nh. Velocity after nth collision is e power nv. Okay. Based on this point, you may, now here we have discussed about the total time. In terms of, if you want total distance travel before it comes to rest, or after second collision or first collision, something like that, how to deal with that is given in the next question number 48. In question number 48, what is mentioned here is a ball is dropped from a height. Question number 48, page number 48. It is given that a ball is dropped from a height h onto a floor of coefficient of restitution e. The total distance covered by the ball just before second hit. Second hit. So same scenario you have to consider here also. What is that? A ball is dropped. A ball is dropped means with initial velocity is dropped from height h onto a floor of coefficient of restitution e, the total distance covered by the ball just before second hit. So first it comes here, it hits first time, this is first collision. After first collision it raises up, it goes to some height h1 s, it goes to some height h1, then again comes back by traveling through same height, and it undergoes second collision. So again it raises to some height h2. Here before second collision, what is the total distance traveled? The total distance covered by the ball just before second collision. So this is that height is nothing but distance traveled. Again h1 is the distance up traveled, then h1 again is distance down traveled before second collision. So you can say the total distance traveled before second collision is d is equal to, before first collision distance traveled is h, plus after first collision it has traveled 2h1 distance before second collision. This is the total distance traveled. But here in terms of e, how to express this? Here again you have to remember this, the height, here distance is nothing but height, right? Height raised after nth collision is given by e power 2n into h. After first collision is given by h1 is equal to e square h. You have to remember this. Okay, so directly you can express this as h plus 2 into h1 is what? H1 is e square h. So if you take h out, then what will you get? The total distance traveled. Then the total distance traveled will be d is equal to h into 1 plus 2 e square. That's it. H into 1 plus 2 e square. Direct formula, right?
So but then I want giving us so once can you
How you try?
sir, I use that h n is equal to e power 2m into h, sir. That formula, sir, but then I did not.
Right?
Yes, sir.
So so all are the simple ones only. So but the thing is you guys have to revise every time, and I mean number of times, then the concepts will be more clear. So question number 58, page number 38. So the question is, a ball is dropped onto a horizontal floor. Okay, dropped means of course initial velocity is zero, just like the previous scenario. It reaches a height of 144 centimeter on the first bounce. On the first bounce means it is dropped, hmm, the initial velocity is zero, from somewhere onto the ground, from some height. We don't know what is this, but it is mentioned that it reaches a height of 144 centimeter on first bounce. Means after first collision or first bounce, it after this is first collision. After this, it raises up and it reaches to height h1. This is equal to 144 centimeters. 144 centimeters on first bounce. Again, it travel down the same distance and reaches the ground and undergoes second hit. It hit the after first hit, it raises to this, then again comes down, and after second hit, it raises to a height of h2, which is equal to 81 centimeters. 81 centimeters, and again comes down the same distance and it undergoes third hit. After third hit, it again raises to a height of h3. Is it given on the second bound? That's it. But you are asked to find the height it attains on the third bounce. If you say it is h3, What is this is the question. So you have to remember simply that the height raised, the height raised after nth bounce, after nth bounce or collision, can also call nth collision or nth strike or whatever it is. Nth bounce or collision is hn is equal to e power 2n into h. 2n into h. Now here it is given that h1 is given. H1 is equal to e power
E power
2 into h.
yes,
This is equal to 144 centimeters. And after second bounce, height raised is h2, which is equal to
4 into
h2 means in place of n if you keep 2,
yes,
e
sir.
power 2 into 2, e power 4. E power 4 into h is given as
81
81
centimeter.
centimeter. Got it?
Yes, sir.
But this you can also write it as is e square into e square h.
Yes,
E square into e square h, but e square h is this. From this we can find e.
yes, sir.
And
So now I understand, sir.
h3 is equal to
E power 6
e
into
power 3 means here 2 into 3 is 6, e power 6
into
h. What is this value is the question. This you can write it as e power e square into e power 4h. E power 4h is 81. If you
So
know,
from these two equations, we can find D value and then
yes,
we substitute in
if
the
you
E
if you
square
take
value.
the ratio of this, we say this is 1, this is 2, this is 3. What is this actually you are asking to find?
power 6
Is equal to what? So let us say 2 by 1.
Yes, sir.
What you will get? E power 4h by
E
e square h is equal to 81 by 144. So e square h cancel, you will get e square here. E square is equal to 81 by 144. Okay, e square, right?
Yes, sir.
Now from this you can write h3 is equal to e square into e power 4h, e power 6h. But e power 4h is 81.
E power 3 only will come.
E power 6, right?
Yes,
Yeah,
sir. Yes, sir.
powers
E power 4
powers will add up, not multiply. So e power 4h. So you can write it as e square is 81 by 144 into this is 80 81 only. So here you can write what do you get 81 square by 144.
So we'll get almost the other three answers won't come, sir. The first answer only will come, sir.
Hmm.
Because the 81, 41, 41, 0 won't come, sir. So the first option will be, sir.
Right,
Yes,
approximately can check with that.
Yes.
So it will be should be actually 9 into 9 whole square by it is 12 square, right? So you can simplify that way also. So simply just you can say that you can do the calculations, right? So what you can write 9 square, the 9 square by 144 is 9 square. Can you write 9 into 9 by 12 whole square? So 3 threes, 3 fours, right? So this 20, 7 by 4. These 4 sixes, yeah, square. 4 sixes, 24. 4 sixes, 24. So 3 remains. Then 3. 4 sevens, 28.
Yes.
Whole square. So it will be approximately more than 36 and nearly 40 something like that. So you can write it as 45.6 approximately. Okay, exactly speaking, we have to cross check them. H3 is equal to 45.6 centimeters. Right?
Yes, sir.
So the simplification process you have to
Yes,
do
sir.
little carefully.
Yes, sir.
Okay.
Thank you, sir.
Okay.